Welcome back again. So this is the part where we will start doing a stoichiometry using what we just learned, molarity. And remember, molarity is defined by the capital letter M, but I told you get rid of that because that doesn't help you. What helps you is molarity is moles per liters. So in other words, you're gonna have a conversion factor that relates molarity and volume. So given the volume, you can find the moles. Given the moles, you can find the volume. And we're going to take advantage of that to use the volume and the concentration to find the moles of reactants or products. And once we find those, then we can use a stoichiometry, the mole to mole ratio, to convert from one quantity to the other. So let's do that with an example. So let's look at this problem. Determine the volume. So we're looking for volume of NaOH. So that's what we're looking for. Determine the volume of NaOH. This NaOH is 0.150, not M, but moles for every 1 liter. So given that concentration, find the volume required to neutralize or to react with 25 milliliters of a 0.150 moles per liter solution. And it's giving us a balance equation. So the 25 milliliters of 0.150 is our ACL. So what I recommend you do is to do something like this. Write the equation in a way you can use it better. Make sure that it's a balanced equation. This one is. And then translate everything you have in the problem, translate it to the equation. What do I mean with that? So we have NaOH is 0.150 molar, so 0.150 moles for every 1 liter. That's your NaOH. And you're looking for the volume. You want to know how many liters are required to react with 25 milliliter or this. That happens to be 0.150, not capital M, but moles in 1 liter. So everything that the problem says, you translate it into the equation. So given the ACL, can you find the volume of NaOH? We know that this is 1 to 1. So if I know the moles of ACL, or hydrochloric acid, I need exactly the same amount of NaOH because it's 1 to 1. So how can I find the moles of NaOH? Of ACL, I'm gonna take 25 milliliters. I'm gonna change that to liters. 1 liter is 1,000 milliliters. So that cancels the milliliters. Now I have the liters, and now I'm gonna use the molarity, which is 0.150 moles for every 1 liter. And these are the moles of ACL. And we know that the ACL, there is 1 mole of ACL, so I want to cancel the ACL, so I put it at the bottom, is 1 to 1 to the moles of NaOH. So let me clear the screen a little bit. Just a second. So when I get to this point, I am now able to know the moles of NaOH that 25 milliliters of ACl require because it's 1 to 1. But I am not looking for the moles of NaOH. I'm looking for what? I'm looking for the volume or liters of NaOH. So I'm going to get rid of the moles of NaOH or sodium hydroxide because I want the liters. And this is nothing more than what? The concentration of NaOH is moles of every 1 liter. So this is nothing more than the molarity, which is 0.150 moles for every 1 liter. That allows me to cancel the moles of NaOH and will give me the liters of NaOH. So let's see how much that is going to be. So 25 multiplied by 1 multiplied by 0.150 multiplied by 1 multiplied by 1 divided by 1,000 divided by 1 divided by 1 divided by 0.150. That's going to give me 0.025 liters. So if I have 0.25 liters of NaOH, that is this concentration, that will take 25 milliliters of that concentration of ACl. So let's reevaluate what we did. So given a balance equation, I can relate the moles of NaOH to the moles of ACl. So if I'm looking for something with NaOH, I need the moles of ACl. I was given the concentration of ACl, and I was given the volume. And as you already learned on one of the previous recordings, if you have the molarity and you have the volume, you can find the moles. So that allows us to find the moles of ACl. And then since we know that this is 1 to 1 based on the balance equation, then the moles of ACl are going to be the same as the moles of NaOH. And using the molarity again, from the moles, I can find the volume. And that's what we did. Let's look at a different problem. A 25 milliliter sample of perchloric acid requires to be neutralized 45.3 milliliters of sodium hydroxide, which happens to be 0.10 molar. And the question is, what is the concentration or the molarity of the perchloric acid that I use? Well, what's given? Well, let's translate everything into the equation first. 25 milliliters of what? Of perchloric acid. So I got 25.0 milliliters. I need 45.3 milliliters of NaOH. 45.3 milliliters of NaOH. The NaOH is 0.101. So this is 0.101 moles per 1 liter or per liter. And given that, I'm asked to find the concentration of this. And remember, concentration is moles over liters. So I need the volume, which I already have. So what I'm looking for is the moles of perchloric acid. So that's what I need to find, the moles of perchloric acid. So given 45.3 milliliters of NaOH, I'm going to change that to liters first. 1 liter equals 1,000 milliliters. Now that I have the liters, I'm going to use the concentration, which is 0.101 moles for every 1 liter. And now I have the moles of NaOH. According to the balance equation, for every 1 mole of sodium hydroxide, I need 1 mole of perchloric acid. So that gives me the moles of perchloric acid. And my so since all I need is the molarity, then let's see how many moles is that. So let's find that. So simple calculation, 45.3 multiplied by 1, multiplied by 1.101, multiplied by 1, divided by 1,000, divided by 1. And that's going to give me 0.0046 moles of perchloric acid. But I am looking not for the moles of perchloric acid, I'm looking for the concentration, which is the moles divided by the liters. I know how many liters I have, 0.025 liters. So I took my 25 milliliters and changed it into liters, and I know how many moles I have, 0.0046 moles. I just found those, right? And once I do that calculation, I can find out that my molarity for the perchloric acid should be 0.183 molar. So the key is, if you have a balance equations, you can find moles from there, but you need moles. Since we know the molarity and the volume, you can find the moles that way. When we did it with gases, we use PV equals nRT to find the moles. When we did it with grams, we use the molar mass to find the moles. So molarity allows you now to find the moles to use on a reaction by knowing the volume, given that molarity is moles over liters, so you can relate the amount of moles to the amount of volume. And that's how you will approach a problem like this. So nothing more than practicing, so go ahead and do that problem. And after you're done with that problem, we can say now that you know how to use concentration and volume to find moles. You can relate the reactant to the product. You learned this on chapter 4 through stoichiometry. And you're going to use the mole-to-mole ratios in the balance equation to go from moles of something to moles of another thing. And from there, you can find concentration if you need to, because you know concentration depends on moles divided by the volume. And with that said, next time we meet, we are going to talk about a new type of concentration, molality. Not molarity, but molality. Molarity is capital M. Molality is lowercase m. Same symbol we use for meters, so be careful. On this case, it just means molality. And I will tell you more once we get to this point. So for right now, let's leave it there. I will see you soon. Take care.